Hello, Assalamualaikum warahmatullahi wabarakatuh. Today I would like to talk about the assignment 2, which is the questions. So we go for the questions. So the question is, a piston cylinder device whose piston is resting on a set of top initially contains 3 kg of air at 200 kilopascal and the temperature which is at 27 degrees. And the mass of the piston is at a pressure of 400 kilopascal is required to move. And heat is now transferred to the air until the volume is doubles. So from the equations, we get information with the pressure 1 is 200 kilopascals, pressure 2 is 400 kilopascal, the mass is 3 kilogram, and the temperature we convert to Kelvin and we got 300 kilo Kelvin, 300 kilo Kelvins, 300 kelvins. Okay. So the FDD of the equation is like at these pictures, which is the air is 100 kilopascal is in the air, and then the piston is required 400 kilopascal to move. Okay, for the questions once, take the energy balance associated with these systems. Okay, as we know that the energy systems, the general energy system is E in minus E out equals to E systems, which is the net energy transfer by heat with mass is for the heat ones, and the change in internal kinetic energy is for the E outs. Okay. So by for these questions, so we know that we have the Q in minus the work boundary out and equals to the change of internal energy and equals to mass, the change of internal energy 3 minus internal energy 1, which is the Q ins. We solve it, we record it, and then we got Q in equals to mass times internal energy 3 minus internal energy 1 and plus work boundary out. So that's all from the questions A. So we go question B. Okay, show the process of a PV diagram. So the PV diagram we should be like this. Okay, uh, the stage one and the stage two is constants because why at the same at the same volumes the temperature the heat is given into the distance, but the only pressure it will be increased but not the volume. Because why we require a 400 kilopascal to the pistons move. So when is the pistons move at 400 kilopascal, it will increase the volume also. So that's the described by the PV diagrams. And C determine the final temperature of the air. Okay, the temperature final. As we know that the initial temperature is 300 kilokelvin at state 1 altitude, which is the volume the same. So as we know that if the volume 1 is same the for the volume 2, and by the formula PV3, and we know that the volume is same, so we got the pressure and the temperature. So which is pressure 1 divided by temperature 1 equals to pressure 2 divided by temperature 2. So we have to find the temperature at the state number 2. So T2 equals to 400 divided by 200 and times the temperature 1, which is 300 kelvins, and we got the T2 is 600 kelvin. So as we know that it will process 2 until 3, which is at the constant pressure, the volume is double, which is the volume at the state 3 is double for the volumes at the state 2. So the final temperature will be V2 divided by T2 equals to V3 divided by T3. It is because why the pressure is same. So the pressure state 2 and temperature T3 is same. So the changes is only for the volume and the temperature. So as we know that the V3 is same with the V double of V2. So we put the V2, we change the V2 on the V3s. So we got, and then we simplify, and then we got T3 equals to 2 T2, and the T3 is 2 times 600, which is a 600 from the T2, and we got our T3 is equals to 1200 Kelvin, and the final temperatures. So the questions D determine the work done by the air. Okay, first of all, we have to find the work done. So we should find the initial volume of these questions. So as we know that at first we have to find the R, which is the constant gas for these questions. it says about the air. So the air is R equals to 0.287 kilopascal megawatt over kilogram kelvins. So we refer at the table A2. So by initial volume, we have to find the formula, which is PV equals to MRT, and then we have to find the V. So V1 equals to MRT1 over P1, which is 3 kilogram times 2, 0.287 times 300 and divided by 200. So V1, we got 1.295 meter cube. Given that volume at the stage 3 is double at the volume at stage 2. So as we know that, so we have to put this V1s because V1 and V2 is same. So V1 equals to V2, and also we got a V3 equals to 2V2 equals to 2 times 1.95, which is V1 equal to V2, the same value, and then we got 2.583 meters cube. So the boundary work process 1 until 2, V1 and V2 is same. So there's no difference in the difference volume. So work boundary 1 until 2 stage is 0 kilojoule, and the process at the 2 until 3, the pressure is the volume is difference. So we have a difference volume. So 400 times 2.583 minus 1.295, and we got 516.6 kilojoule. So total work boundary out is 0, the state 1 plus the state 2 and state 3, and we got 516.6 kilojoule. Or the alternative way, we just using this formula, which is V boundary out equals to integrate 1 until 2 states equals to pressure and differentiate of volumes. So PV times the change of the volumes, which is volume 3 until the volume 2, and then we got the answer is same, which is 516.6 kilojoule. So determine the total heat transfer to the air during the process. So as we know that, so to find the total heat transfers, we have to find the internal energy for these questions, which is at the pressure 200 kilopascal and temperature is 300 kelvins. We refer the table A17, and we got at the 300 kelvins, the U is 214.07 kilojoule per kilogram kelvins. So at 1200 kelvins, as we know at referring by table A17, we got 933.33 kilojoule of a kilogram kelvins. So the heat transfer we is using the energy balance by the questions is, so Q in equals to M U3 minus U1 plus work boundary out. So we put the formulas, and then we put all uh, the numbers into this formula. So Q in equals to 3 kilograms times 9323.33 minus 214.07 plus 516 and 516.6 kilojoule. And then we got the answer is 2674.38 kilojoule. So that's all from me for this question ones. So Assalamualaikum warahmatullahi wabarakatuh, and thank you.